Okay, today's video is the one that you've all been waiting for. Arc length and sector area example problems. I know you all love your example problems. So we've got quite a few here. For numbers 3 through 8, we're going to find the length of each arc. Now, I'm going to try to get this moving pretty quickly because there are a lot of problems, and I don't want to make this video super duper long, but I might break it into 2 videos. We'll see. So let's look at number 3. We're looking for the length of this arc all the way around, and our angle is 3 pi over 2. Now that's weird. It doesn't tell us whether it's in degrees or whether it's in radians. And here's something that you should probably note down. If there is no unit, you assume that it's radians. And that's why in the past, I've always asked you to make sure to put the degree mark anytime you mean degrees, because if you just don't put any mark at all, it's going to be assumed that you are in radians. So we are 3 pi over 2 radians. Now, here's a quick review. Arc length is the radius times theta when theta is in radians. When theta is in radians, you just have to take the angle and multiply it by the radius, and you're done with the arc length. That's why we set radians to be the size that they are. So we may as well take advantage of that shortcut, because that's what this is for. So the arc would equal the radius, which is 16 feet, times 3 pi over 2 radians. 16 is over 1. Remember, any whole number is actually a fraction, which is itself over 1. And 16 and 2 are both divisible by 2, so we get 1 on the bottom, 8 on the top. Multiply straight across the top, straight across the bottom, and we get 24 pi. And we're going to leave the answer exact this time. Let's move on. Number 4, we are looking for this arc, which is made with this central angle, which is pi over 6 radians. Okay, well, same deal. Remember, arc equals the radius, which is 13 inches, times the angle in radians, which is pi over 6. I put the pi over 6 in parentheses just to remind myself that it's multiplication, but you don't have to. I don't see anything to cancel here. 13's prime. So our answer, somewhat anticlimactically, is 13 pi over 6. Oh, units. Square inches. Let's go back to the first one. 24 pi square feet. Can't forget those units. They're important. Okay, let's move on. This time we're not given a circle, we're just given a radius and a theta. And this theta, for number 5, is in degrees. So let's remind ourselves, in degrees, you have to take theta and divide it by 360. And again, that is theta in degrees. And you multiply that by 2 pi r. Man, radians make it so much easier. Okay, so to solve this problem, we're going to take 60 degrees divided by 360 degrees, and we're going to multiply that by 2 times pi times the radius, which is 18. Now, 60 divided by 360 is 1/6. Try it out for yourself if you don't believe me. No, really, do it. And then we get 18 times 2, which is 36 pi. Right, that's 2 times 18. And now 6 and 36 are both divisible by 6. So we get 6 pi. 6 pi what? Centimeters square, or centimeters. Ooh, I messed up my units in the past ones. That's embarrassing. But I'm going to leave it in because, once again, mistakes are okay. These are not square feet and square inches. I was jumping ahead to the area problems later. We are looking for the length of an arc, so this should have been inches, and this should have been feet. Sorry about that. Okay. Now let's see if I can section these off. Actually, yeah, let's see if I can section these off a little bit. Okay, so there's that problem. Let's go ahead and do number 7 first, and then we'll go over to the other side. We've got a radius of 9 feet and an angle of 7 pi over 4 in radians. Okay, so our arc length is going to equal the radius, 9 feet, times the angle in radians, 7 pi over 4. I don't see anything that cancels. 9 times 7 is 63, so you get 63 pi over 4 feet. Again, it is amazing how much easier this process is after we invent radians. So I'll give you a sec to take a look at those two. Pause the video if you need to. All right, let's move on. We've got 2 more. One is degrees, one is radians. I have a feeling we're going to end up doing the same thing that we just did. Take a second, pause the video, look at your notes from the last 2 problems, see what you can do. The problem is exactly the same, but you're going to have a couple of different numbers. Okay, let's give this a shot. So if the radius is 16 meters and theta is 75 degrees, then we get 75 over 360 times 2 pi times 16, right? 2 pi r. Okay, well, I'm seeing a lot of canceling that can happen here. I used a calculator to reduce that to 20 pi over 3 meters. If you don't remember how to reduce using common factors, it's a really good practice, so you should probably give it a shot. All right, one more, at least in this series. We've got a radius of 14 feet. We've got theta is 19 pi over 12. Okay, let's give this a shot. Arc, now we're in radians, which means we're using the simplified formula. So it's 14, the radius, times 19 pi over 12, the angle in radians. Um, 14 and 12 are both divisible by 2, so I get a 6 on the bottom and a 7 on the top. Whew, 7 times 19. Let's see. 7 times 20 would be 140, minus 7 would be 133. I hope I got that right.
The answer is 133.
Man, I'm good at this. Okay. What were the units on that? Feet. And again, since we're staying exact, we're just going to leave it like that. We could use a calculator to get a decimal if we wanted to, but nah. So that's our video for today. Okay? Tomorrow, I will release a video with sector area, both in degrees and in radians. And we'll do that next time. As always, if you have any questions, please put them in the comments or email me or show up to a Zoom meeting or do anything to reach out and contact me. I have plenty of time during the day. Please ask me your questions. Not a lot of people have been showing up to my office hours, and not a lot of people have been asking me questions via email, so I'm starting to worry about you all. So let me know if you need help. Thanks for watching. I'll see you next time.